Hi, so I'm going to present you how we can use Capella models, and it's a semantic previously defined by using the Gmod Studio in order to better understand how the models are behaving and the impact of the export of the models to other tools. So let's start by exploring the execution of this model. So we are going to create a debug configuration here with the name of the model and the name of the language, which is here mainly the function scenario which are used in the model. Here is a graphical representation we want to animate, and let's start it. So here the process is actually constructing a file which represents the semantics, the behavioral semantics of the models, and this behavioral semantics will be used to animate the corresponding models, the corresponding diagrams. So we have mainly in our model three diagrams, which are a function scenario, a data flow bank, and an allocation. So here it is, so it opens. So here you can see the allocation of different tasks on a GPP and different actors which are other functions, and all of this correspond to this scenario here. Oops. So we present the data flow and the scenario here. Okay. And here you got different steps which are supported by the semantics. So what we have is a set of tasks here to T2, T5, T6, T7, external actors which are also functions, and a scenario. You can see that it's split in two parts, one part for the aircraft position T6, T5, T7 and the camera, and another part with processing and T2, and these two parts are independent so that actions can be actually interleaved together. And the different tasks you can see here are all allocated on the same computing unit, so that we cannot execute two of them at the same time. So here this model is actually independent of any scheduling, meaning that it represents a set of acceptable schedulings, because this model is not refined enough to know a specific scheduling. So let's see all the possible steps. So you can see lots of them, but you can just explore things by choosing one, like this one. So I choose one step, and what it says that okay, I can start by this place in the model executing aircraft position, which actually send the data to T6. And here you get some feedback on other views, like aircraft position have been activated and suspended, and T6 is activated. We can decide, for example, to start T6 after that. So let's start it. So it highlights there and there. Of course, it can be suspended at any time by other tasks like T2, which are competing for the resource, which is the computing resource. But we're not going to do that now. So we are here, we just started T6, and you can see that we can execute for 4 steps for milliseconds in our case, before to send a synchronous message to T5. So let's see that. So let's run T6 one time. So it's reported on this view. We can still prompt. Let's execute it a second time, the third time, and so now one we can see that next time we are executing T6, we are actually activating T5 here. Here it is, a message and send, and of course T5 can be started. So T6 is expand, T5 is started, and so on. It can execute in between 4 to 7 milliseconds. So 1, 2, feedback is given here, 3, 4, and so now what you can do is continuing to execute T5 until the 7 times, but we can now terminated it because it already 4 times it's executed. So let's execute one more millisecond, okay, 5, and then you can choose to stop it. Okay, so what we call feedback is given. This function is now stopped. This one is ready to start, and the return of the function is here, so that we can start again the T6, okay, which started there and which can continue to execute, okay, for 9 hours time before the set happen, etc. What we can see if I just continue to execute T6 is that at this time this is an asynchronous call, so T7 will not be need to be started at this time, but will be only activated at this time. So let's go for it. So 7 here. Oops, sorry. 8, 9, 10. So it's 9 plus 4, so it's 13. 11, 12. Okay, so now okay, 13. So now we need to activate T7. T7 will be activated here. Okay, but will not be started. So you will have feedback here, it's activated, and now either we decide to start T7 or to continue T6, or even to start another task which suspend the T6, like for example T2 in this case. So we switch in between the different functions now, and now T2 is activated, ready to be started, and we can explore the different solutions. Here we have to better understand the different impact of both the allocation, the scenario, and the data flow in between all these functions. Okay, so that's fine. It can help somehow to better understand our system. We can ask for a random play of this, so that we will have some randomly chosen stuff. For example, here we get some suspension and T7 which start, etc., etc. Okay, let's start that. Here it's a general tool, it's Capella. What we sometimes want is to export this model to a dedicated tool, and this was done in Thales by using the Tempo tools, which is a tools for schedulability analysis, which provides some traces. And what we want to know is that after the export, after a connector to this specific tools, does this trace actually satisfies or conforms to the semantics that was given in the previous model. So we will use the execution model, the result of the compilation of the model with the semantics which was created during the execution before, and we select the trace here, and we can ask to the timesquare tool to create a new specification which is actually constraining the execution of our model according to this trace. So now we can go back to the debug configuration here and go to the advanced tab to say, okay, I would like to see what's happened if I constrain my execution with this trace and explore by myself the results. So here you will relaunch the execution, but this time only considering the one which are correct according to the trace. So as you will see, you will have less solutions, of course, in your different execution, but not a single one, because the Tempo tools is actually considering only the green tasks here and not all of them. What it means is that it partially resolved the model execution, but not so once the motor is launched with the trace forced in the simulation, we can see that it's no more possible to execute aircraft position or T6 because the trace is stating that T2 is starting first at time 1. So now the only possibilities we have is to start T2 or to let time passing. So let's start T2 and follow the trace, so everything is working. So now T2 is working until time 18. So, and of course we still have graphical feedback, so we can continue to play the trace, but something which is interesting here is that we can also explore what is not forced by the tool, meaning that let's see, here we are executing 17 times as asked here, and then T2 is terminating, and here the tool is not speaking about external actors like pre-processing, so we are still have freedoms to choose what it should or should not do. So in between the step 18 and the step 24, where T6 must be activated, we have freedom to execute pre-processing as we wish. So for example, we can decide to first and suspend it, and then we can spend time, for example 1, and we can start pre-processing and run it for 1 and for 2 before to stop. And we could have choose another solution here, like for example I can explore another trace, like okay, let's go back at this time. I want now to spend time first 2 seconds and then see if I can start and run directly pre-processing here. That's okay, that's a valid trace. I'm not it's not mandatory to stop it now, but we have to start T64 because it's required by the trace. Okay, so let's do that, and at some point we can decide to stop pre-processing as needed here. Okay, so it means that we can now explore the things which are not fixed by the trace, and by saying that, it means that we can also explore wrong way. So for example, we can say, what does it mean to go in this direction when time is passing without doing anything? So let's do it 1 time, 2 times, 3 times. Of course it's a deadlock because we should have been able to send this message here after 4, after the start of T6. Okay, so another question we could have is it possible to force the trace to one possible path and remove all this direction that goes to deadlocks? So we can do that. So what we have to do for that is to analyze the spec which is created there, and to ask to the tools to verify all possible executions and to keep only the interesting one, meaning the ones which are not going to deadlocks. So let's do it. Here the tool is constructing the whole state space of the trace, exploring the different solutions at the different time given in the trace. And it will end up with some graph representing all the different executions of the systems. And based on this, it will extract one of the paths which goes to the end of the trace if it conforms, or to the last state where the trace is actually violating the specification. And by doing so, we'll be able to re-inject the trace like done with this one to play exactly the path in the tool. We will see that. So once the checking is finished, you got a verdict. So here it says that trace conforms the specifications, and you get the whole state space here, which is represented here to show you or to save the different execution paths that were possible. You also got some new specifications, which is a specification of one execution which is valid and does not provide any deadlock. So now you can go to the debug configuration in the advanced tab and choose this time the second specification which was just created by the analysis. When you ask for debugging of this specification, you will no longer have different choice for pre-processing and so on, but only very few choices where it does not change the simulation. So most of the time you will have a single step to play. So let's see that. It is. So here, now the only choice, you cannot spend time doing nothing because it goes to a deadlock. So the only choice is really to start T2 now and then to execute it for 17 steps as required. So of course you still have your graphical feedback which help understand what's happened, and it clearly follows one of the execution paths which is correct according to the original specification. So it helps to understand what was the result of the analysis of the tools you used, and will give you some traces. Okay, so let's execute until the end of T2. Okay, here it is. So it terminates, and it terminates also T2. So here everything was fixed, and pre-processing will start, and so on. Single choice at each step. Okay, so it clearly replaces the traces in your original environment, helping you to understand it. Of course, sometimes it can happen that some hypotheses from the external tool which was used were wrong. So if the tool is wrong, I change one of the line here to say, oh, some things happen at times 22 while it should not, or perhaps I can introduce something which I'm sure is something wrong, like, okay, if this is suspended at 25, so the analysis, so let's make a little cleanup here. You can ask to generate new specification according to this trace. So this new specification is created here, and we can ask for the analysis of these specifications. So the tools actually explore all the possibilities once again, but when it will end up on 25, it will understand that it's not possible to do it for the reason that you should have 4 milliseconds, so it crashes and tell you that the current time where it crashed up was 25, and it will provide you the graph of executions here. So it crashed up there. Okay, so you can detect trace that does not conform to the specifications, and once again you could here have replay, because you got the trace of the error, so you can replace in your model until the error, like before with the animation, to understand why the tool provides you with a wrong trace, and try to perhaps fix up the transformation or talk with the tool provider and so on. Just a last thing to make you understand, when I'm speaking about the graph of execution, here I saved some result which was a result of the checking of the trace, and it provides you this kind of graph here, when you can see all the possible executions starting from the left and going to the right, and red parts are where something happened from the trace, and the other parts are where something is not fixed by the trace. So you can see that the execution is a mix of both, and some of the execution just end up in deadlocks. So we computed on the fly the longest path here represented in greens, where the execution is correct according to the trace, and this is the one which we are actually replaying in the environment. So the first spec you saw which were playing represented this whole set of executions, some of them going to deadlocks, and the second one, after analysis, plays only the one which is interesting because it goes to the longest path without deadlocks. Thank you, bye bye.